So we want to do something kind of reasonable. So this question is on IUPAC nomenclature. So probably your tutor has sent you a video on this. So CH3, you have a compound like this, an organic compound like this. They ask you to name it. How will you name this? We have A. So they said A, isopropyl ethene. They said B. They said acetylene. They said C, 3-methylbutane. They said D. They said 2-methylbutane. So E, they said 5-methylbutane. Now, how do you do questions like this? So the rule of IUPAC nomenclature is that if you guys don't know it, you can ask me to teach you. Now the rule is that you choose the longest carbon chain. Which one is the longest? Is it 1, 2, 3, 4? Or you can start from this 1, 2. Don't say because it's not straight that you cannot count it. So 1, 2, 3, 4. 1, 2, 3. Which one is the longest? You can go this way. 1, 2, 3, 4. So that one is long. This one also is long. 1, 2, 3, 4. So automatically we want to use the straight chain so that it can be easy for us. So this is our first carbon. You should start your naming from where the branches is closer, from where it is closer to the branches, the substituent. This CH3 is a substituent. So you should start your naming where the substituent is closer to the branch, to the terminal substituent or element or chain. So I'll start my naming here. So this is 1, this is 2, this is 3, and this is 4. Now on the second carbon, this is how to name any carbon chain that does not contain hydrogen. Instead of combining with hydrogen directly, that carbon chain is what I'm going to be naming anything that falls around it. If you look at this, only this place, carbon does not combine with hydrogen only, but it combines with what? CH3, which is called alkyl group. The alkyl group, they have this general formula: CN H2N plus 1. Most of the time they will represent them by R. So if they represent a compound with R, just know that R represents what? Alkyl group, and this is their formula. This is their general formula: CnH2n plus 1. Now if you want to name, now you will now be saying the CH3 here is what? C1 H2 times 1 plus 1. So that is CH3. So it means this is called what? Methyl, because one carbon in organic chemistry means met. So just add this prefix, the suffix rather, to it, so it will give you what? The compound. So we now have 2-methyl. So the rest of them, they have no substituents. So this one is the what? Substituent. So that's what we are going to be using. So we now have for 2-methyl. Now how many carbon do we have? We have 4 carbon, and 4 carbon means boots. And if you look at this, do we have any double bond? So if you know that there's no double bond there, drop it in the comment section. So we have no double bond, so that is what? Butane, ane. So we now have what? 2-methyl butane. So that's our answer. So our answer here is what? Option D. So the reason why we cannot pick ethane can never be the answer because there is no double bond there. Acetylene also cannot be there because we don't have triple bond. I think acetylene is the same thing as ethane. So if I can still remember, so acetylene is ethane. So ethane it has triple bond, so it cannot be. And also 3-methylbutane. Now we cannot start our naming from this place. Hadn't been we start our naming from this place, we are going to be saying 3-methylbutane, and that's wrong. I hope you understand. So we cannot say that. So I hope you understand. So let's continue. So our answer is a 2-methyl butane. So that's just it. So that's how to get your IUPAC nomenclature. So let's leave organic chemistry for now. Let's still go to another aspect that I've not touched you. I think we should go to let's go to this area. Let's go to this area. There's a lot to learn. So this area is a chlorine, nitrogen, and sulfur silicon. So let's do that area. Don't forget we have what we call so there's something you need to know. I don't want to be using something that I don't want to be going from one topic to another. Let us just be doing a year. Let me go to a year and let us start working from the beginning to the end. I don't want to just be growing from one topic to another. I want us to be looking at them one after the other. So we have a diagram here that catched my attention. So this is the diagram. They draw something like this. They draw it like this. So this is the return stand. They just draw everything like this, like this. So that's just it. That's how they draw the diagram. They now say these are our particles. Don't mind my diagram. That's how I draw my own. So we have the heat source. We have so this is called the hex. This liquid or solid rather. So they now said we have this. So we have this. Sorry, I need to draw it very well. So it's a question on preparation of nitrogen gas. So we draw our beef chef, our beaker, our beef chef. Don't forget, I told you method used for collection of water. Which type of collection is this? Which collection is this? Which type of collection is this? This one is upload development. This. This is collection over water. This is water. It will not be glowing. So this is our nitrogen gas. They now said, what do we burn? They are now asking us that, what do we burn to get the compound? That is, what is this X? What is this X? That's what they're asking us in the question. So that's what they're asking us in the what? In the question. They're asking us what is X. So if you know what X is, you can drop it in the comment section. And if you don't know it, let us know. So actually, what X is the potassium nitrate and copper tonics. That is X. So that is what? That is our X. Potassium triosonitrate 5 and copper tonics. And our another question they ask on this was that the oxide that remains unchanged when heated in hydrogen is. So I don't think this question is on the what we are doing, but they just put it out and under it that the oxide that remained unchanged when heated. So they talk about this compound. Don't forget they said the X is what? KNO3 and what? Copper tonics, that is Cu. I hope you understand. So that's what they said is our X. So that's the answer. So don't forget that. So they are now telling us now that the oxide that remains unchanged when heated. So actually this question I kind of think it was this compound. Do we have more than one way of producing nitrogen gas? So we have more than one way of producing nitrogen gas. So we have more than one way. So just check your notes and do that. So let's do this. Okay, let's use our board like that. I saw the diagram I want to see. I want to see this diagram. So it's a popular diagram that you need to know. So they draw it like this. I like this diagram. Yes. So actually I'm going to draw the two diagrams for you. So it is two diagrams. They have two. Hope you understand. So this is the second diagram. So one of the diagram is for exothermic reaction and one is what? For endothermic. So let me quickly try. Assuming this is 20 and this is 10. So this will be that of products and this will be that of reactants. And you know that exothermic reaction, the delta H is normally what? Negative, and for endothermic, delta H is always what? Positive. So let's try it. So it is actually delta H is HP minus HR. So the ones that is going to give us negative would be exothermic, and the one that will give us positive is endothermic. The one that will give us negative is exothermic, and the one that will give us positive is what? Endothermic. Exothermic negative, that is delta H will be negative. So what's our HP? HP is 10. 10 minus 20, so that is minus 10. So I'm just using that one to test it. So automatically this is our HR and this is our HP. So HP is less than HR. So our delta H will be HP minus HR. So that's an exothermic reaction. So this diagram represents exothermic reaction. Now we have a lot of things in this diagram. So I forgot to write this is representing the energy axis and this is representing the. So this diagram is very, very important. The reaction parts. This is the reaction part. Here also is the reaction part. And don't forget your energy is measured in what? In joule. Though it depends. It depends. So energy here also. We have our reaction pathway. So that's our reaction parts. These are our reactants. These are our products. These are our HP. These are our HR. And also here also our delta H will be HP. Always it will always be HP HR. So it will be positive. Here it will be negative. So this one is endothermic reaction. When the enthalpy change is positive, you know that we are what? Under endothermic reaction. Now there's a place here also. There are some things you need to know. So the distance between, there's a place, so here also, so they will draw some things here. So the diagram here is something here. So this place is called activated complex. So this place also is called activated complex. So also here also. So now you know that this is a reaction. We have reactants and we have products. Now there's something we call activation energy. When they are talking of activation energy, this activation energy is like an hindrance, just like a resistance. So it is the minimum amount of energy barrier that must be overcome before a reaction can take place. So when we use a catalyst, what we are trying to use, that we are using catalysts to lower the activation energy. I hope you understand me. So catalyst, kind of, you know that they said catalyst is used in what? In increasing the rate of reaction. So it means catalyst lower the activation energy so that the reaction can what? Occur faster. Now assuming this is how the reaction is going to go, like this, like this, like this. Instead, when we use catalyst, the reaction is just going to go like this, little and go back like this. Instead of passing this long stress, it's just going to go like this. Now the total, sorry for this, from this place to this place is now called the activation energy for uncatalyzed activated energy for so it's called the uncatalyzed reaction. So this is the what? Activation energy for what? Uncatalyzed reaction. Why the distance from this place to this place is called the what? Activated energy for catalyzed reaction. Please take notes. Catalyzed means a reaction we have used catalyst for. So without even telling you, you should know that the same thing will happen here also. I hope you understand. The same thing will happen here. So I don't need to be labeling it for you again, because the same thing will happen. I hope you guys are understanding. So that's just it. So that's how to do questions like this. Now there's now a place called the rate of reaction. There's a place called what? The heat of reaction. So the heat of reaction is from this place. You know that this place, I said delta H is what? HP minus HR. So the distance from this place to this place is called the what? The heat of reaction. Is the what? Heat of reaction. So just does what the question asks us to do. Is the what? Heat of reaction. So it means from this place to this place here also, it will be our what? Heat of reaction. Please know the labeling. The labeling is very, very important. But there are some questions, they will give you 30 here, They will give you 20. They will now say you should find the delta H of the reaction. So you just say, what's our HP? 20. Just put it there. What's our HR? That is 30. You will now get what's minus 10. They will now say, what should you deduce from this question? Since you get a negative, you're going to say the reaction is a what? An exothermic reaction. They may do it here also similarly. They may say this is 30. They may say this is 20. You now be saying 30 minus 20. So that's what? 10. I hope you understand. So that's just it. So it's very, very simple. So that's just it. So let's continue. So let me quickly wait a little bit for you guys before we continue. Alright, this video is still connected, so let's continue. So please guys, be responding. You're not dropping any comments. Please respond. So let's continue with the class. So I like that. I like the energy. So we have done a lot. Please write something down. If you're not writing something down in this class, you are wrong. Now I quickly see a question here, and it catches my attention. It catches my attention. If they draw a compound like this, they said the formula for ethyl butanoates is A C4H9 COO CH2H5. That's the first thing. B C2H5 COO C4H9. So we have C CH2H5 COO CH3H7. We have these two. So now they now said which of the following is the formula for ethyl butanoates. Now when this compound is an ester. What do we call ester? Ester are alkyl alkanoate compound. How does it form? An alkanoate compound, they are organic compound with fruity odor. Please take note of that. They are organic compound with what? Fruity odor. That is, they have fruity smell. Most of the drinks you drink, they are not using really fruit. They are using what? Flavor, just flavor. So if you had, so it is ester. What they are kind of unique that they have orange flavor, that it will look exactly just like orange drink, and you didn't know that it's just a chemical. They have maybe a lemon flavor, things like that. So they have it. So they are compounds. So you should know that. Now, how do we form alkyl alkanoate or ester? They are formed by the reaction of alkanoic acid with alkanol, and reaction is a reversible reaction, which will now give us ester and water. Yes, ester and water. Do you get? So just it. So alkanoic plus alkanol, ester and water. Now the forward reaction is called esterification, while the backward reaction is hydrolysis. And the catalyst that we use is conc. Catalyst that we use is the what? Conc H2SO4. So that's the what catalyst used. Do you get? So that's the catalyst used for the reaction. So please follow with me. Now, they now say we should name the compound. Now, this is how to do it. Ethyl, methyl, ethyl, they are compound from alkyl. And alkyl, they have the formula CN H2N plus 1. Their first member will be N is equals to 1. N is equals to 1. That will be C1 H2 into bracket 1 plus 1. That will be CH3. And CH3, when we have one carbon, it is normally met. And because of the surface YL, we are going to be having what? Methyl. The second member of alkyl will be CH2. 2 times 2, 4. 2 plus 1. So that is what? 5. So that the second member will be what? Ethyl. The third member will be propyl, fourth butyl, and so on and so forth. Now, this is how you name an alkyl alkanoate or ester. You start, when you mentioned it ethyl, you are going to start from the back if you want to name them. So it means I'm starting from the back whenever I want to name an what? Ester. So it means ethyl. So this option A and option B, they are looking like the answer. Ethyl, we already have the ethyl, yes. Now, for you now to know what will be your butanoate, anything like but in organic chemistry is represent 4, which means what? 4 carbon. Now, don't go and pick this option because this is not 4 carbon. We are going to count this and this. 4 plus 1, so that is 5. So you will know that that one is not what? 4 carbon. But look at this one. We have C, we have this. You will count this C together so that you can know the total number. So this and this, so that is 4 carbon. So that will be what? Ethyl butanoate. So the answer is what? Option D. So just it. It's very, very simple. So if you want to name this compound now, CH3, COO, CH3. We start from the back. So CH3 is what? Methyl. You count this and this. So that is 2 Abi. What is 2 in organic chemistry? That is 8. Then you put anoates. That's all. You can see that very simple. So you can try this and drop it in the comment section. C5. I don't want to give you something. Okay. C5 H11 COO C5 H11. So let's try this. This is C5. That is pentyl. If you know the answer, you can drop it in comment section. This is 1C. 1C. So that's the 6 carbon. And when 6, you use mathematics X. So X and weights. So that's it. So you can see it's very, very simple. You must not name only this. You will name it. You will add this to this. So we have 5 carbon here plus 1 carbon. So that's 6. So let's continue. So we still go to another aspect. Now, this is calculation. So I want to do calculations like this before. They said what volume. So this calculation is very, very important because they normally ask it at times. So what volume of oxygen will remain after reacting? The reason why I'm laying emphasis on chemistry is that chemistry is one of the subjects that's very simple, but most students fail it. So that's it. Some students fail it, so that's it, and it's very simple. So we have option A, 10 cm cube. We have option B, we have 12 cm cube. We have option C, we have 14 cm cube. We have option D, 16 cm cube. So now they now said what volume of oxygen will remain after reacting hydrogen with 20 cm cube of oxygen. So we react hydrogen. What is hydrogen? Hydrogen is represented by what? H2, right? hydrogen plus oxygen. You should know the product as a chemistry student. That whenever we react hydrogen and oxygen, we will always get what? Water. Except at times that we form peroxide. Hope you understand. It's not every time, but we normally form peroxide at some time. Now, how do we balance it? We have two hydrogen here. We have two hydrogen here. We have two oxygen here. We have one here. So let's put two here. Now we now have four oxygen, four hydrogen, and we have two hydrogen here. So let's put two here. 2 times 2, 4. 2 times 2, 4. So everything is now balanced. Now this is what you'll be doing. They now said we have. This is what you'll be doing before you now use the volume they give us. You will say we have initial volume, initial mole. You'll be using mole for them. We have 2 moles of hydrogen, right? So you say 2 moles, 1 mole of oxygen, and we have 2 mole of water. They now said what volume of oxygen will remain after reacting 80 cm cube of 8 cm cube of hydrogen with 20 cm cube of oxygen. So whenever you are doing something like this, you will kind of use the ones that is easy for you. So for you to do that, they said we have 8 cm cube of hydrogen. So that will be hydrogen is lower than hydrogen than that of 20 cm cube of oxygen. So that we will be using 8 cm cube of that of hydrogen. So we have 8. Now you notice that whenever we have 2 moles of hydrogen, we are going to be having what? 1 mole of oxygen. So it means when we have 2 moles of hydrogen, we'll be having what? 1 mole of oxygen. Now when we have 8 moles of oxygen, what mole do you think we are going to be having? So if you know the answer, drop it at the comment section. So automatically the most we'll be having is what? 4. So it means we have what? 4 cm cube here, 8 cm cube here, 4 cm cube here. Automatically what will be here? We'll be having what? We have 2 moles of hydrogen here, 2 moles of water again, so it will be 8 cm cube here also. But mainly we are working on this and this because that's where our question is on. So let's continue. So what else do you think we will do again? So if you know the answer, drop it in the comments section. Now they said we now use what? 20 cm cube of oxygen. Now you look at the question now, we just have 4 cm cube. We just use 4 cm cube, and they said we react 20 cm cube of oxygen. So it means after we have used 4 cm cube of oxygen, how many oxygen is going to be left from this 20? We have used 4 and we supply about 20 cm cube of oxygen. How many volume of oxygen do you think is going to remain? So if you know the answer, drop it at the comment section. Now we react 20 cm cube of oxygen and we use just 4. So the volume of oxygen remain now. Volume of oxygen remain will now be what? 20 minus 4. So that will be 16 cm cube. I hope you understand. So this topic is very, very simple. Just be comparing them together and you will get your answer. So let's still go to a question. Another question you need to know. Yes, let me check. Now, when they draw a reaction like this, CaO plus H2O, and you form a compound called CaAO inside. They now said the process. What's the name of this process? They now say what's the name of this process? They now said dissolution. They now said slaking. They now said liming. They now said mortaring. What do you think will be the answer? If you know this, drop it at the comment section. So the answer is actually slaking. Why? Because CaOH2 is kind of called, this is called, I told you earlier that this one is called quick lime. I hope you understand why this one is called the what? This is called the slaked lime or the lime water. Please take notes. There are some things you need to take notes. If you are not writing, you are wrong. A minute. If you are not writing, you are wrong. So pick your pen now and write. So you hear the word slaked. Yes, you hear the word slaked. So it means a lime that is slaked. So quick lime, CaO is what? The quick lime. Why the CaOH into bracket 2 is the word slaked lime or lime water or calcium hydroxide. Do you get? So that's it. So now they now said the process of forming slaked lime, process of forming slaked lime. So automatically it will be what? Slaking, not slimy. So liming is the addition of base or an alkaline or a lime to a soil to make it reduce the number of acidity in the soil. So it's different. The solution is when you dissolve a salt in water. So let's continue. I just saw that one on my way to the questions that I want to do. So I said I'm still looking for other questions that we can still do. So let's quickly let me go to another area. I think I should do a calculation. Yes, let me do a calculation so that you guys will not be lagging behind on calculation aspects. I hope you understand. So let's quickly do a calculation. So they say 20 cm cube of a solution. Sorry. 20 cm cube of a solution. So containing 0.53 gram of anhydrous Na2CO3 in 100 cm cube. So they say it requires 25 cm cube of H2SO4. So for complete neutralization, they now said, what else? They now said the concentration. We should find the concentration of acid solution. So in mole per dm cube. In moles per dm cube. So now says, so our option is A, 0.02 dm cube, mole per dm cube rather, because they are asking us concentration. So our answer should be in mole per dm cube, though they themselves they put cm cube as their option. So you should know that it is mole per dm cube, and mole per dm cube you can represent it by M, that's capital M, or you can write mole per dm cube direct. So it's either way. Don't forget capital letter, it represents mole per dm cube. So we have 0.04 M 0.06 m. Then we have D, 0.08 m. Let's write our molar mass. We have the hydrogen, that is 1, carbon, that is 12, oxygen 16, sodium 23, and our sulfur is 32. They now ask us to find the concentration of acid solution in moles per dm cube. Now, if you notice, they didn't tell us the name of the acids. Okay, they tell us the name of the acid. They said H2SO4. So now it means H2SO4 is reacting with what? Na2CO3. As a chemistry student, you need to know the expectation. Whenever you react a reaction together, you need to know what it's going to give you. Now, neutralization, you need to know that neutralization is that of when acid reacts with a base to form salts and water. So our equation must be giving us salts and water. Now, to do that in an organic chemistry, you will join these together, then you join this together. Please, do you get? Join this together, join this together. That will now be Na2SO4 plus, though it's not always the case every time, but at times. Now, you see there that we get a salt. This is a salt, but this is not a water, it's an acid, but a weak acid. Now, this compound is not stable. After some times, it's going to break down. So we're now going to be having Na2SO4 plus H2O plus CO2. I hope you understand. Now, this CO2 is a gas, so it will fly away. So we are left with what? Just water and Na2SO4. Now, I want to ask you this. Is this equation is it balanced? So automatically looking at it, the equation is what? Balanced. We have 2 hydrogen here. We have 2 hydrogen here. We have 4 oxygen, 5, so 7. So we have 7 oxygen here. So the equation is what? Balanced. Now, there is something we call number of mole of acid. Number of mole of acid is what we use to balance the hydrogen, the acid here, and what we use to balance the base here. Now, adding being we have 2 here, our number of base will be 2, but we don't have base. We don't have anything in the front of it, so it means it is still 1. Whenever they don't write anything at the back, so it is still what? The coefficient is still what? 1. So our Na is what? 1. That is the number of mole of acid. Don't forget that number of mole is the number they normally write here. Adding it is 5. We're going to be saying our Na is what? 5. But because they said 1, because they don't put anything there, if you look at this equation, they didn't write it for you. I'm the one writing it, because no one will be drawing. It's not every time they will be writing equation for reaction for you. You need to know the outcome yourself. So don't be confused that, well, how did I get the reaction? I get it from the question. So you too should learn how to just do something. So Na is 1, Nb is what? 1. Now, there's now a formula in organic chemistry, which is N is equals to Cv. Now, N is the number of mole, C is the concentration, V is the what? Volume. Now, we now have Na is equals to Ca Va. We also have Nb is equals to Cb Vb. Now, at the end of the day, we can say this is our equation 1 and this is our equation 2. So you can now set equation 1 divided by equation 2. So we now having Na over Nb is equals to Ca over Va over Cb Vb. Now, in these questions that we normally do, most of the time you may be using this, but there's still a formula, and this one is the most authentic. At times, before you do a question, that's the first thing you should firstly think of before doing a question, and the formula is conc in mole per dm cube, and don't forget it's still represented by capital M, is equals to conc in gram per dm cube over molar mass. So that's just it. And molar mass is measured in gram per mole. Now, the question now says 20 cm cube of a solution containing is 0.53 NO2CO3 is 0.53 gram of anhydrous Na2CO3. Whenever you have a question like this, that they are saying maybe they said 0.63 gram in 150 cm cube. Whenever you have a question like this is the arc. You will say 0.63 gram gives you 150 cm cube. I hope you understand. The main aim is for you to convert this to dm cube. Now you now be saying 1000 cm cube here. You will now make this your x, then you cross multiply. The aim is that we want to get gram per dm cube, because gram per dm cube is in this equation, so that we can quickly get our answer. Now we're now going to be having 0.63 times 1000 divided by 150. So anything we get, assuming, I'm just assuming you, I don't say that's our answer. Anything you get will now be in what? Gram per dm cube. Do you get? Now that's not what we are doing. They now said what? They now said 0.53 in what? In 100 cm cube. They now say 0.53 grams. So that will be what? In 100 cm cube. So don't forget our rule. You'll be saying this is 1000 cm cube and this is what? X. Then you cross multiply. You'll be having 1000 times 0.53 is equals to 100x. So 100. So we now have what? 100. So we now have this. We have this. So our x now will be what? So it will be automatically 53. Okay, sorry. 5.3 gram per dm cube. So you can see it's very simple. Just know the approach. That's all. Now, this 20 cm cube they wrote in the front, it represents the volume of the base. This VA represents the volume of acid or volume of A. I hope you understand. This VB is the volume of base. This CB is the concentration of base. CA is the concentration of acid. Na is the number of mole of acid. Mb is the number of mole of base. Now we have known our Na, we have known our Mb. We are now looking for concentration of B, and this concentration of B is what? It should be in mole per dm cube. Now if you notice, what we just got now is what? It's just gram per dm cube, and we must get what? Mole per dm cube. Which formula do you think we are now going to use? So as a serious student, you know that this is what we will be using. Now, how do you now get your conc mole per dm cube? Looking at the formula, it should direct you that the next thing for you to do is to find the what? The molar mass. And what is the molar mass for Na2CO3? Now Na2CO3, they've given us the molar mass. For sodium it is 23, so you put times 2. The molar mass for carbon is 12. The molar mass for oxygen is 16, so you just say 16 times 3. So at the end of the day, we are going to be having 106 gram per mole. Now what is conc in mole per dm? Conc in gram per dm cube that we got? We get 5.3. Conc in gram we get for molar mass is what? 106. So let's press our calculator. Let me press my calculator. So we'll be having 5.3 divided by 106. So we have 0.05. So that will be our what? In mole per dm cube. That's 0.05. So that will be our what? That will now be our what? CB. 0.05 in what? Mole per dm cube. Now we've gotten our Na to be 1, our Mb to be 1, our VB to be 20. Please take note. Our VA now, what is our VA? Let's go back to the question. They now said requires 25 cm cube of H2SO4. Now you ask me, why don't I use this 100 cm cube for the VB? The reason is that this 100 cm cube is representing the 0.53 in 500 cm cube. So it means this 0.5, this 100 cm cube belong to this 0.5. I hope you understand. So it's different. They now say requires 25 cm cube of H2SO4. So it means the volume of acid needed. That is our VA. 25 cm cube. Now if you look at this question, these parameters in our formula, CAVA over ZBVP is equals to NA over NB. Now which parameters do you think we are here to get? If you know the answer, put it in the comment section. Now the parameters we are here to get is the what? CA. Now since we've got the rest, we substitute it in the question and we make our CA the subject of formula, then we get it. What's our CA? What is the question asking us before we? Now the question also is asking us the concentration of acid solution in mole per kg. Yes, that's what they're asking us. So CA. So CA now will be, what's our VA? 25. What's our CB? That is 0.05. What's our VB? That is 20. You notice that I don't convert my VB. VA. The reason is that VA is in cm cube and my VB also is in cm cube, so it will cancel each other's out. That's why I don't need to convert again. But normally when they ask you to find the number of mole of acid, you have to convert your volume to dm cube by dividing by 1000. Don't get me wrong. And if you like it this way also, you must convert here also. If you like, you can convert. And how do you convert? You divide by 1000. You convert to dm cube, because dm cube is the standard unit for volume under this topic. Now what's Na? 1, Mb 1. Let's cross multiply. We're now having Ca times 25 is equals to 20 times 0.05. So let's press our calculator. We have Ca 5 over 100 times 20 over 25. You now have 0.05 times 20 divided by 25. So our Ca now is what? Is 0.04 mole per kg. So that's capital M. So we're looking at our question. The answer is what? Option B. So you can see it's very, very simple. Just that it takes our time. Don't be discouraged. So it's kind of simple. So do you get? So let's continue. So the video is still up and running. We are still. So I'm going to be ending the video soon because this battery system is running down. But before that, let me still do some things before we round up. Now I've taught you this in the previous video, so now I want to know whether you are following. They now said, which of the following gases rekindles glowing splints? Which of the following gases? I want to know if you guys are watching the videos. Which of the following gases will rekindle? You can see that the things we do is we come out. This is a jump question. Rekindle a brightly glowing splint. Now what is the answer? They said their option A is NO2, NO, N2O, CO2. If you know the answer, drop it at the comment section. So the answer is a nitrogen 1 oxide, and that is this. I called this laughing gas that day. So it rekindles glowing splinter. So we have two gases like that. That's rekindles glowing splinter, and also oxygen also. So oxygen and nitrogen 1 oxide, also called as laughing gas, N2O. Both of them, they what? They rekindles glowing splints. So take note of that. Now here they ask question on atomic radius. So there's a question on atomic radius. They now said we should find question on atomic radius. So they don't normally ask question on atomic radius, but this question this year they ask it. They said the distance between the nuclei. Please, guys, ensure you solve a lot of past questions. And I don't say you should not read though, but solve a lot of past questions. You now say the atomic radius of chlorine atom is yes. I now understand them now. I understand them. A, they said 0.097 nanometer. They said P 0.914 nanometer. They said C 0.388 nanometer. They said D 2.388 nanometer. Now, this is how to find the atomic rate. They said the distance between the nuclei of chlorine atoms of chlorine molecule. Please, you need to know the difference, especially for gases that are diatomic. When they are talking of diatomic gases, they are like oxygen, hydrogen, nitrogen. All those gases that have two, they are diatomic gases. Is that all? I think we say yes, chlorine. What else again? So these gases, they are diatomic. That is gases that have. So one molecule of oxygen is this, but one atom of oxygen is just O. I hope you understand. Hydrogen is, this is hydrogen molecule. This is nitrogen molecule. This is chlorine molecule. But the atom of chlorine is what? Just Cl. Atom of hydrogen, nitrogen is just N. Atom of hydrogen is just H. So a molecule of oxygen is different from atom of oxygen. Unlike metal, that they are monoatomic. That this will be a molecule, this will be their own atom also. So there's a year that they ask us that mention two monoatomic gases. So monoatomic gases, they are gases that are noble gases. Noble gases are what? Monoatomic gases. An example of them is the helium, neon, argon, etc. So argon, neon, they are monoatomic gases. And don't forget, they are non-reactive. They have because they have duplet or octet configuration. So that's just it. Now, they now say the distance between the nuclei of chlorine atoms of chlorine molecule is 0.194 nanometer. They now say the atomic radius of chlorine atom is, now if you look at chlorine molecule, I say it is 2 of atoms. So it means we have 2 atoms of oxygen in oxygen molecule. We have 2 atoms of hydrogen in hydrogen molecule. We have 2 atoms of nitrogen in nitrogen molecule. You notice that I put triple bond. It's because nitrogen has triple bond between its compound, between its molecule. So just know that. That's why it is nitrogen don't really react very well. And chlorine also is like this. So chlorine, we have 2 atoms of chlorine in 1 molecule of oxygen of chlorine. Now we now said we have 0.194 as the atomic radius for chlorine for the molecule. So it means that of the what? Of the atom will be 2 times. So the atomic radius will be 2 times. It will be 2 times the atomic radius of the what? Of the atom. That is the chlorine atom. I hope you understand. So 0.194 will now be divided by 2. So that will be what? Atomic radius of the atom, chlorine atom, will now be 0.097 nanometer. So that will be our what? Answer. I hope you understand. But hadn't been they said the chlorine molecule, and this is the chlorine atom, you just say 0.9194 times 2, because chlorine molecule is greater than atom. So that's just it. So I think we'll be rounding up here. So let's still look for some things we can really play with. I'm looking for a question that we can really play with. Yes, yes. This is a question here. It's also a calculation. Maybe we should be focusing on calculation for now, on chemistry. You guys will have to read. Chemistry, you read it. There's a lot of things to read in chemistry. So they said an element Z contained 90% of Z16/8. So once we finish with this question, we will be rounding up the class. We have 10% of Z18/8. They now said its relative atomic mass of is what? So they are now giving us the 16.0, 16.2, 17.0, 17.8. So blah 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 blah. Now this is the formula for you to find the relative atomic mass of any compound. So this phenomenon is called isotopes. What is isotopes? The occurrence of an element to have what? The same atomic number but different mass number, or different number of neutron. I hope you understand. So that's just it. So this is isotopy. Now whenever they ask you to find relative atomic mass for an element like that, it will be mass of the first element, that is first isotopy, times the relative abundance plus the mass. I'm going to be explaining further now. The second mass of that compound and the relative abundance of that same compound. This alpha that I'm using is the one in percentage. I hope you understand. This one also is the percentage. I'm not meaning this one, Yari. This one will be percent. This one is the percent. Now, the first compound they gave us here, they said it's contained 90%. So it means our alpha 1 is what? 90%. And I told you that any number they put on the top is the mass number. And this is the what? Number of proton, or the atomic number. This is the atomic number or number of proton. This is the mass number. Don't forget, I said this is the, assuming we have an element X, A, Z, I said this will be our mass number, and this will be our what? Atomic or proton number, or proton. So that's just it. Now, it means the mass of the first compound is, the first element is 16. That is M1. Now, the second element, the relative abundance, they write it for us to be 10%. They give us the mass also, which is what? I made a mistake here. No one here. So it's 18. So let's just substitute our question. Then we get our what? Relative atomic mass. So though the question may be other way around, that they will ask you to find relative abundance of 1. They will give you the relative atomic mass. They will give you relative abundance for 1. And they will ask you to do it. Relative atomic mass will now be, what's the mass of the first one? 16. The relative abundance is 90%. So you just say, you know that percentage has to do with 100. So 90 over 100 plus 18 times 10 over 100. So by now, you guys should not be afraid of calculation again. We have 16 times 0.9 plus 1.8. So we have what? 16.2. So our relative atomic mass now is what? 16.2. So our answer here is what? Option B. So let's round up here. And if I still see a question, I will still feel like doing it. So because there's no time for us to waste. So but because of our time, I'm afraid we have to round up here. Yes. So round up here. And let me look for a question I can quickly do. Okay, I seen a question. So that's it. Once I see a question, I will feel like doing it because the time is gone. So it's also a calculation, but we need to be fast because the system is come out. They said what volume What's volume of A is 0.1 mole per dm cube. Don't forget this M, capital M, is mole per dm cube. H3PO4 will be required to neutralize. So this also is like just like the one we did the other time, 45 cm cube. So this question, if you are not very careful of it, it can be somehow tricky, of NaOH. So yeah, they now say we should find the volume of a 0.1 mole per dm cube of H3O4. So it means what did they ask us to find here? Is it VA or VB? So if you know the answer, drop it at the comment section. So our so that's our VA, because they've given us our VB already. That is, this NaOH is the base, so that's why he said, but they have given us 45 cm cube of NaOH. NaOH is a base, H3O is the acid. So this is the equation for the reaction. Now the formula we'll be using is CAVA over ZBVB. Without even telling you, you know that this Na and Mb, they depend on, we need to know the equation for the reaction. If we don't know the equation for the reaction, we cannot do it. I hope you understand. So these are the things that will guide you when you are doing calculations. So now let's write the equation for the reaction. H3PO4 plus NaOH. Don't forget our formula. This one we paired with this. This one also we pair with this. So we now be having NaOH. Normally in chemistry, you are not allowed to be writing like this. You should write everything on the side, but because of our space, so it will be Na. It should be PO4, right? No, you cannot write it that way. The reason that this PO4, let me write it for you. This PO4 and H, before they combine, this PO4 is in 3 minus and plus is here. And don't forget our rule. This one will come here. This one is come here. So it means this one will be H3PO4. So that's how we form it. It's not that we are just drawing a compound. So here also, sodium is Na plus, and PO4, don't forget, is always 3. 3 will come here, plus will come here. So it means I cannot write NaPO4. It must be Na3PO4. Now, this H3 combines with HO. So that's just maybe H2O. H2O is what we must form. You cannot be saying H3, H4O. So there's no compound like that. Now, what we are now going to be doing is that we are going to balance the equation. Now, we have 3 hydrogen here. We have 2 hydrogen here. We have 3 sodium here. We have 1 sodium here. We have 3 sodium here. So let's balance by putting 3 here. Now, how many sodium do we have? We have 3 sodium. We have 3 oxygen. 3 oxygen here. 4 oxygen here. So we have 7 oxygen. We have 4 oxygen here. We have 1 oxygen here. So let's quickly balance. How do we balance? We have our oxygen is not balanced, right? So how do we balance the oxygen? So the oxygen is the one giving us problem now. We have 3 oxygen here. Now how do we balance? How can we make our oxygen to be 3 here so that we can have 7? We have 4 oxygen here. We have 1 here only. So by doing so, we put 3 here. Now we now have 7 oxygen. So it means our oxygen is balanced. Now hydrogen, let's take our hydrogen. We have 3 hydrogen here. Yes, 3 times 1, 3 hydrogen here. We have 3 hydrogen here. So that is 6 hydrogen. Here also we have no hydrogen. Okay, we have 6. 3 times 2, we have 6 hydrogen. So it means our hydrogen is balanced. So it means our equation is balanced. Don't forget. Now I told you the coefficient of the Na, of the A, of the acid will be our Na. So we write nothing in the front of H3PO4. So that will be 1. But here we put 3 at the front of the base. So our Mb now will be 3. I hope you understand. So let's now substitute into the equation. They asked us to find Va. They said of A, 0.1 mole per dm cube of H3PO4. I told you that is representing your Ca, 0.1 mole. Will be required to neutralize 45 cm cube. So that's Vb, 45 cm cube. and our CB is what? Is 0.2 mole. Then we get our Na 1, Nb 3. Let's now substitute. We now have 0.1. Our Va is what we are looking for. Our CB is 0.2. Our VB 45. Na is 1. This is 3. Let's cross multiply. We are now going to be having Va times 0.1 times 3 is equals to 0.2 times 45 over 0.3 is 0.3. So Va is equals to 0.2 times 45 over 0.3. So we now have what? 30. So we now have what? So 30 cm cube. So our answer is a Va now will now be 30 cm cube. So it's, you know that is very, very simple now. So that's our volume of the volume that will be of 0.1 that will be required to neutralize 45 cm cube. So that's just it. So you need to know how to do questions like this. So this is where we draw the curtain for today. I hope you guys gained something. So I think I need to pay attention to calculations, because I want you guys to be good in calculation. So this is where we draw the curtain for today. Bye.